Hello students, I welcome you all in this another video where we are solving integration board exam questions. Now this question was asked in the CBSE examination. Its weightage was 3 marks, under 3 marks. Okay, so let us try to solve this question. Now in this question it is said that evaluate limit 0 to pi by 2 modulus of sin x minus cos x dx. Now for solving this question, first of all you need to understand the mod. You cannot solve this question. Before solving this question you have to first of all remove this mod, or you have to solve this modulus first. So we will try to understand what the modulus function is basically. So modulus function is, suppose mod x equals to, it is x when x is greater than or equal to 0. It is minus x when x is less than 0, which means if you put a positive value in this function, for example mod 5, then it will give you 5, and if you will put a negative value in this modulus function, then it will put a negative, one more negative in front of this minus 5, and it will make it positive. So mod always gives us positive value. If we will put negative value in this modulus function, then it will make this negative value positive. Okay, so that is the rule. Now here what happens is we have to integrate this question, we have to integrate this function from 0 to pi by 2. Now we must be aware of this function sin x and cos x, how it behaves in the quadrant 0 to pi by 2, or in the limit 0 to pi by 2. So we know that the values of sin x is increasing, the value of sin x is increasing from 0 to pi by 2, and value of cos x is decreasing from the interval 0 to pi by 2. So here in this question, now from 0 to pi by 4, okay, we have to check the values from 0 to pi by 4. For example, if I draw the table sin x and cos x, so if we take 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. So the value of sin x at 0 degree is 0, and 30 degree it is 1 by 2, 1 root 3 by 2 and 1. Now cos x here at cos 0 will be 1, cos 30 will be root 3 by 2, and cos 45 will be, sorry, this is 1 by root 2. Cos 45 will also be 1 by root 2, and cos 60 will be 1 by 2, and cos 90 will be 0. Now if you look at the values of these functions from 0 to 45, 0 to 45, from here to here, so what will be the result? If you will subtract sin x minus cos x, for example 0 minus 1, what you will get? You will get a negative value here. Sin x minus cos x will give you a negative value. Here also 1 by 2 minus root 3 by 2. If you subtract 1 by 2 minus root 3 by 2, what will happen? It will give you a negative value. It will also give you a negative value. So here we are getting negative value, and here we will get 0. Now from here onwards we will get positive value. Sin x minus, for example, sin x minus cos x, and 1 minus 0 is positive. So actually what is happening, from interval 0 to pi by 4, from 0 to pi by 4, sin x minus cos x gives us, sin x minus cos x gives us negative value. Sin x minus cos x gives us negative value. Okay, so what is the role of modulus function? Modulus function, if there is any negative value in the modulus function, then it will make it positive by supplying another negative sign. Okay, so from this question can be break into 0 to pi by 4. 0 to pi by 4. See, sin x minus cos x will give you a negative value, so modulus function will put another negative sign to make it positive. See, this sin x minus cos x is negative, already negative in the interval 0 to pi by 2, and modulus function has given one more negative sign to make it positive. Now from pi by 4 to pi by 2, sin x minus cos x is already positive. So for positive, if we put any positive value in the mod, then it will give you positive value itself. So this will be sin x minus cos x. So in this manner we have to break down this question. We have to break it down, limits from 0 to pi by 4 and pi by 4 to pi by 2. Now we can integrate it. Further we can rewrite this question as, that 0 to pi by 4, you can write it as cos x minus sin x. Cos x minus sin x, multiplying this minus sign inside the bracket. So it will become like this, pi by 4 to pi by 2, sin x minus cos x dx. Now we have to integrate it. Now what is the integration of cos x? The integration of cos x is sin x. The integration of cos x is sin x, and integration of sin x is minus cos x, and already the minus sign is there, so it will become plus cos x. Lower limit and upper limit. We will put the lower limit and upper limit. Now plus, here also the integration of sin x is minus cos x. The integration of sin x is minus cos x, and integration of cos x is sin x, so it will become minus sin x. Okay, now we will put the lower limit and upper limit here. So this we have integrated. We have integrated the function. Now we will put the upper limit minus lower limit in the function. So here if you see the first part, first we will put the upper limit. Okay, first we have to put the upper limit. So upper limit will be sin pi by 4 plus cos pi by 4. So what it will give you? Sin pi by 4 plus cos pi by 4 minus, then we will put the lower limit, sin 0 plus cos 0. Okay, so if you will solve this, then sin pi by 4 is 1 by root 2 and cos pi by 4 is 1 by root 2. So what you will get? 2 by root 2, and this can be written as root 2. So finally we will get root 2 here. Okay, we will get root 2, and cos 0 is 1, so root 2 minus 1. We will get root 2 minus 1 on solving this. Now here onwards, here again you have to put the upper limit minus lower limit. So if you will put the upper limit, then cos 90 will be 0 and sin 91. So you will get a minus 1 here. Okay, and when we will put the pi by 4, minus pi by 4, so we will get minus 1 by root 2 and minus 1 by root 2. So it will become minus root 2, and we have to put a negative sign also while subtracting upper limit minus lower limit. So ultimately we are going to get 1 by 1 minus 1 plus root 2. This we are going. Okay. 1 minus 1 plus root 2. Now if you will solve this, then you will get 2 root 2 minus 2. So that is the answer, 2 root 2 minus 1. Okay. Okay, so there is another question, that is evaluate integral 0 to pi by 2 e to the power x dot sin x dx. Now students, basically this is the question of indefinite integral, but in board examination it is been asked as a definite integral. So what we'll do, we'll try to solve it using indefinite integral. So first we will find the indefinite integral of this function. The function is, let us consider I equals to, consider this integral as indefinite integral. So it will become I equals to integration e to the power x sin x dx. Okay, we will take it as a indefinite integral here. Now we will apply the method, that is the integration by parts. Okay, so there are basically three methods, out of which one method is integration by parts. So integration by parts will apply here. So there is a concept here, we follow the rule, that is isolate. Now what is the meaning of this? I means inverse trigonometric function, L means logarithmic function, A means algebraic function, T means trigonometric function, and E means exponential function. So this isolate basically gives us an idea of the preference of the function, that which function we have to take as a first function and which function we have to take it as a second function. So there are two functions here, that is exponential function, this is an exponential function, and this is the trigonometric function. So this gives us the idea about the preference. So t comes before e, so we will take sin x as the first function. So here we will take sin x as the first function, sin x as the first function, and e to the power x as the second function. Okay, now we'll apply the integration by parts. So integration by part is what? Integral, if there are two functions, integral u v, then this can be written as u integral v minus integral u dash integral v. Okay, so in this way we can write it down, dx, and here also dx, and this is also dx. So in this manner we can integrate it. Okay, so apply this concept here. So this will become I equals to, now our first function is sin x, so sin x, keep it as it is, integrate e to the power x dx minus integration, open square bracket, d by dx of sin x, that is the first function, and again integrate the second function. Okay, like this. So we have applied the concept of integration by part here. Now what we will get? Now integration of e to the power x dx will be e to the power x, so e to the power x sin x, this will become e to the power x sin x, minus integral, here d by dx of sin x is cos x, so it will become cos x, and e to the power x integral is e to the power x. So this we are going to get. Okay, now again here we will get integral e to the power x cos x dx. So we have to again apply the integration by part here. So again we will apply the integration by part, that is, this will become, see minus sign is there, so open a square bracket, you can open a square bracket. Now again we will take the trigonometric function as the first function, so cos x integral e to the power x dx minus integration d by dx of cos x, and integral e to the power x dx and dx, like that. Okay, so we will get e to the power x sin x minus, now here integral of e to the power x is again e to the power x, so this will become e to the power x cos x. Now dy dx of cos x is sin x minus sin x, and minus one more minus sign is there, so that it will be multiplied to minus sin x, so it will come out as plus integral e to the power x sin x, like this, dx. Okay, now this is again the question that we have started with. This can be written as I, because it is the same integral that we have started with. Okay, integral e to the power x sin x dx. So here in place of this you can write I, e to the power x sin x. So here you can write I, so e to the power x, open the bracket, you can also open the bracket, so this will become e to the power x cos x minus e to the power x integral, sorry, we'll write it as I, okay. Now this is the minus I, so minus I will, when you will transpose it, then here on the left hand side it will get added with this I, so 2I equals to e to the power x sin x minus cos x, we can take it as common. Now I becomes 1 by 2 e to the power x sin x minus cos x. Okay students, so this is the step by step process. Now actually the question was like this, integral 0 to pi by 2, the question was integral 0 to pi by 2 e to the power x sin x dx. Okay, so this was the question. So we have found out the integral of this function. Now I'll put the limits, as the limits is given to us, so we'll put the limit. So 1 by 2 is the constant, so here only we'll put the limit e to the power x sin x minus cos x 0 to pi by 2. Okay, 0 to pi by 2. Now we'll put the values. Upper limit first, so 1 by 2 is here. Now first we will put the upper limit, so it will become e to the power pi by 2. Now sin pi by 2 is 1, and minus cos pi by 2 will be 0. So this will come out to be e to the power pi by 2. Okay, then we'll put the lower limit minus lower limit. So e to the power 0 will be 1, and sin 0 will be 0, and this minus cos 0 will be minus 1. So here already a minus sign is there, so it will become plus 1. So it will come out to be e to the power pi by 2 plus 1. Okay, so now we'll multiply 1 by 2 inside, so 1 by 2 e to the power pi by 2 plus 1 by 2. So that is the solution, complete solution of this question. Okay, in NCERT it is given as a indefinite integral, but in board exam the examiners always, the paper setters always make some twists and turns in the question, so they have added this as a definite integral. So I hope you understood the whole question step by step, and if you like the video, then you can hit the like button and share with your friends, and also subscribe the channel. So here is another question, students. Find integral x square upon x square plus 4 into x square plus 9 dx. This is also a 3-mark question, and you can clearly understood that this is a question from partial fraction. Now partial fraction is a very important topic in the chapter integration, and by looking at the question you can easily identify it in the exam. Okay, So this is a question of partial fraction. Now here in the numerator x square is there, and in the denominator x square plus 4 and x square plus 9 is there. So first of all, before applying the partial fraction, there is a condition we have to check first. The condition is that the overall degree of the numerator must be less than overall degree of the denominator. Okay, so degree of numerator should be less than the degree of denominator. Okay, so always check this, then only you can apply the partial fraction, otherwise you cannot apply. Now if you'll solve it, then this can be done as means, for example, we want to break it in the partial fraction, then this will become x square plus 4 x square plus 9. Then as per the concept learned in the class, we can break it as a upon ax plus b upon x square plus 4. Now why ax plus b? Why we are taking ax plus b? Because x square plus 4 cannot be further reduced to the linear factors. It is a biquadratic factor and it cannot be further reduced. We cannot reduce into the some linear factors. So it's a biquadratic factor. If biquadratic factors are there, then we take it as ax plus b upon x square plus 4. So ultimately we have to take 4 variables like a, b, and then here cx plus d. So the question, this is also a right method, but the question will become very complicated because there are 4 variables involved and you have to find the value of each and every variable. Okay, so here you can apply a trick. The trick is that you can take x square equals to t. You can take x square equals to t. Okay, because everywhere in the question x square is there, so you can take it as t and then you can proceed. Okay, now this is not a substitution. This is not a substitution method that we have discussed in the integration, that there is a method that integration by substitution. So that is not we are applying here. We are simply applying a trick, that is x square is everywhere, so we can take x square equals to t. If we would have applied that integration by substitution, then we have to differentiate it also 2x dx equals to dt like that, but we are not going to do it here. Okay, so if this type of question will come in the exam, then you have to proceed it like this only. Okay, so the question will become like this. The question will become I equals to integral t upon t plus 4 and t plus 9. Okay, and this is t plus 9. Okay, so we will take it only, this only. Okay, we will take this only, this part. Okay, now taking this only, we will try to apply the partial fraction. We will find the value of a and b. So this can be written as t upon t plus 4 can be written as t plus 9 equals to a upon t plus 4 plus b upon t plus 9, b upon t plus 9, b upon t plus 9. Okay students, now we are only concerned with the numerator, so here in partial fraction we take numerators only, we take comparison of numerators only. So this will become a bracket t plus 9 plus b bracket t plus 4. Okay, this is it. Now you can find the value of a and b using first of all, you can put t equals to minus 9. If we put t equals to minus 9, if we put t equals to minus 9, so what will happen? This term will become 0. As soon as you put t equals to minus 9, this term will become 0. So this will become minus 9 equals to this a into minus 9 plus 9 will become 0 plus b and here you can put, in place of t you can put minus 9 plus 4, so this will become minus 9 equals to, now here you will get minus 5. Okay, minus 5, so minus 5 b, so b will become 9 by 5, so b will become 9 by 5. The value of b will comes out to be 9 by 5. Okay, now similarly, now you put here, see, you can see the linear factor is t plus 4, so 0 of this linear factor is t plus 4 equals to 0, which means t equals to minus 4. Minus 4 you can put here in place of t. So if we put, if t equals to minus 4, then what will happen, this term will become 0. Okay, b into t plus 4 will become 0, because in place of t, if you will put minus 4, then this second term will become 0. So this will comes out to be minus 4 equals to a minus 4 plus 9, so this will become minus 4, and what will get 5, so 5a, so the value of a will be minus 4 by 5. This we have got. So in this manner you have to find out the values of a and b. Now this can be written as, we have had t upon t plus 4 and t plus 9. So this can be written as, now we have the value of a minus 4 by 5, so this can be written as minus 4 by 5 t plus 4. In this manner we can write it, and the value of b is 9 by 5, so we can write it 9 by 5 t plus 9. Okay, so this is we have got. Okay, now you can the values, you can put the values, so this will become, you can again substitute the value t equals to x square, as we have assumed in the starting that x square equals to t, so you can again replace t by x square, so this will become x square, so this can be written as, x square by x square plus 4 x square plus 9 equals to minus 4 by 5 x square plus 4 plus 9 by 5 x square plus 9. Okay, so using partial fraction we have derived this expression. Now we can integrate this expression, so integrate both sides. So here you can integrate this is integration, dx and dx, so you can integrate it. Okay, now for integrating you can take minus 4 by 5 as outside the integration, because this is the constant, so this will become like this, plus you can also take 9 by 5 outside the integration, and 1 by x square plus 9 dx. This is it. Now we will integrate it. Now there is a formula for such type of integration. The formula is integration 1 upon x square plus a square equals to tan inverse, that is tan inverse x by a plus c. That is the formula that we are having. Okay, so the formula is 1 by a tan inverse x by a plus c. Now we'll apply this formula. So what will be a here? Now 4 can be written as 2 square, here the 4 can be written as 2 square, so the value of a will be 2 here, and here 9 can be written as 3 square, so value of a will be in this case 3. So you apply the concept here. Then this will become minus 4 by 5. 1 by a means 1 by 2 tan inverse x by 2 plus 9 by 5. 1 by a means 1 by 3 tan inverse x by a, and plus c is the constant. Okay, now this 4 will get cancelled by this 2, so this will become 2, and here also 9 will be cancelled by 3. So the answer will be, final answer will be minus 2 by 5 tan inverse x by 2 plus 3 by 5 tan inverse x by 3 plus c. So that's the answer of this question. This is the answer step by step.